Okay. Let's see what we got. Good. That went out. Oh, I should close out some of this stuff. Skip this time. All right, folks, give me 2 seconds. Okay. Pop out. Yeah. Go. There we go. Hello. Welcome to MicroCinema 4K, the highest quality live stream microscopy in the world. I'm Jason, and yeah, good to see everyone again. Hello, Teeny. Hello, Marcos. Let's see, we got Cahuinha here. That's a little Portuguese, a little maybe Brazilian Portuguese. And yeah, thanks for showing up, everybody. And we'll get to it here. So let's see. So today I wanted to kind of start off by talking about a something new that I tried out this week, and I meant to get it. There wasn't a stream last weekend. I was a little under the weather, but I set it up last weekend, and then today is the first time I'm actually trying out what I set up. So I want to talk a little bit about that. I think it's kind of neat. And so here we go. So a while back, I got these, which oh boy, you can't even really read anything that's on here. But this is basically a stack of sieves of different. They kind of each one pops off, and each one has a little mesh inside of it of a different size. And I don't have my bag. I ordered in addition to these sieves, I picked up a 1 kilogram of glass microspheres of like a nominal. I think it was nominally like 150 to 175 microns. And I had the idea of using these glass microspheres in between my cover glasses and my slides as like little spacers. And so initially I just took some of these spheres and like threw them on a slide, and it really did not help at all. It was just kind of like having sand on the slide. Any of you that are, done some microscopy, if you've ever gotten like a sand grain on the slide, you know how extremely annoying that is. So that didn't work. So then I put the microspheres through the sieves, and so I would just put in like a teaspoon and shake them down basically, and I ended up getting basically a whole bunch in the 90 micron to 125 micron gap, and then as well I also got a bunch in the 50 micron to 75 micron gap. And so I ended up with two little vials here. One of them has spheres that are sorted to be 90 to 125 microns, and the other one has little glass spheres that are 50 to 75. And so then I took just a teeny tiny, like a few little micrograms out of each, and I mixed it together with some Vaseline in these little tiny petri dish, plastic petri dish things. And so the idea was I created this sort of little paste, which has these little glass microspheres embedded in it. So for those of you that aren't familiar, one thing that you can do to sort of keep your cover glass from smushing your organisms is to put some dabs of Vaseline in the corners. This is something that Feisner wrote about. And I've found that to be kind of unreliable, especially because if it's really warm, then the Vaseline is like very soft and flowy. And so when you put the cover glass on, it just smushes anyway. Um, so the idea is basically to kind of get those spheres in there to, the spheres will not get mushy essentially. So tonight's the first time I'm trying it out. I got some samples from some salty marshes in the area, and I think it worked out pretty well. We'll see. I think I actually got we have some really cool samples tonight. I found some really interesting ciliates, like a whole bunch of these ciliates that I've never seen them before. And they were like I think they were like the perfect size for the 90 to 125 micron spheres. So I've got a slide of those prepared. We'll see how that works out. And yeah, I'll try it out. You guys we'll see. Okay, let's get going here. So if you're new here, first time, we usually start out with a prepared slide. And so this is a prepared slide. Let's see, this is, it's Virginia Creeper. So it's a stem, it's a cross section of a stem from Virginia Creeper. And it's from Cornell Biological Station in Jersey. And they're, or maybe, yeah, I'm assuming that's, I don't think Hornell is the name of the preparer, but I could be wrong about that. So I'll go away here and we'll get the show on the road. Okay, so right now we're using a 2x objective. So this thing is not quite a quarter of an inch, maybe I don't know, 3/16 or so. Of course, that is, the proper measurement system. 3/16, very natural to measure things in that way. And so yeah, this is a true like histological sample here. And it's a very, very, very thin little slice of a stem. Let's see if you can pop this up. Yeah. Might go in there. And just turn this down to the point where it gets good results here. And yeah, this is just a lovely little plant stem. I don't think the Virginia Creeper is a particularly rare plant. But it is interesting to see how it looks in cross-section here. And, I apologize in advance because I don't really know anything about Virginia Creepers or plant morphology or anything like that. But I know one thing that we can do, and one thing that is often observable, is we can put this thing under polarized light. And, because, again, when you think about polarized light, you should always be thinking about directionality. You should always be thinking structures that have some intrinsic direction to them. And I think it's just a matter of fact that a lot of plants have kind of these structures that grow with like fibers that all run in one direction. And so in polarized light, you can get some pretty neat imagery out of these thin sections. Back to the 2x. Oh, over. Let's see what's in the way here. Oh, there we go. Very pretty. Very pretty little, simple little section here. All right. So let's go ahead and swap over to our first wet slide of the night. I'm going to take this off. And pop it back in my box of slides. All right. And we will start off with the oh, they're still on here. Yeah, they're still on there. Okay. Oh, let me take switch out my objective turret here. There we go. And I'm also going to switch out my condenser. And let's see, we'll pop this bad boy in. So I gotta kind of rebuild my microscope here. Okay, I think that's it. Yeah, okay. And let's go to the 4X here. Boom. Let's take this bad boy out. Let's pop in our DIC analyzer. And see what we got. Oh, I see some little stuff running around. Good sign. Dun, dun. Boom. All right. There we go. All right. Oh, whoa. All right. Here they are. Here's one of them. Oh my goodness. What are you? Here we are, we're in Brightfield. Let's see if I turn this down here. Whoa, is it actually pink like that? Let's see, let me make sure I didn't. Yeah, I got that. Whoa. It looks kind of Stentor-ish. But I watch these things swim around, and they are definitely not Stentors. Or if they are, they're very unusual Stentor. And there are a whole bunch of these things. I promise you guys, we're going to get our fill of these. That's for sure. Okie dokie. Look at that. Let's see, I think we'll have more of these to look at. We better have more of these to look at. So I'm going to go back to the 10X. We will hunt around. But it's looking pretty good so far. So, you know, what I was kind of angling for with this slide was to basically have these things. Here we go. Yeah, what I got? This looks like. There we go. So to basically, you know, ideally when you're looking at like ciliates, you don't want to crush them. You want to just kind of like have them just barely between the slide and the cover glass. And so that was the attempt here. In fact, we can go up to these. Here, this is the corner of the cover glass, and you can see all these little spheres embedded in it. Ah, yes. And here are my strange little specimens. There's some different sizes to them. Look at these things. Maybe that other thing is a stentor, and these things are different. Whoa. What the heck? Look at these. Oh, these have such a weird like morphology. They almost have like a like with stentor, there's sort of that like spiraling in oral cavity, but these are clearly not stentor. And this is you know, a marine marsh. So this is wow, look at this big one here. Look at that thing. Oh, and it's definitely got some kind of like pinkish pigment to it. Whoa, whoa, whoa. But this is cool. This is exactly what I was hoping for here, which was when I prepared this slide, I really didn't want to smush them. I wanted them to be able to like swim around freely, so that you could really see their morphology. Because a lot of times what happens is when you sort of just haphazardly put ciliates onto a slide, you can kind of smush them. And so the whole time you're watching them, you don't realize that you're watching them in sort of a smushed state, not really as they are when they're swimming around. And so these, you can tell by just how fast they're swimming. But this is, they're pretty free to move. But they're also, they're not, like, I'm not having to change the focus too much. So they're kind of like right in between the top and the bottom. This is awesome. Wow, look at that thing. Hey, Teeny, see ya. Dude, I have no idea what these things are. This is definitely, like, I've never seen anything like this in freshwater. When I was looking at them through the stereoscope, I was like, oh, maybe they're kind of like Loxophilomish or something, because they have this kind of pointy end to them, but now that I can see them, they're definitely not that. And there's some, like, look at that variation in like the pigment. Some of them are real dark, some of them are pretty light. Wow. Yeah, we got some folks from Australia, from Mexico. Welcome in, everybody. Yeah, we got some other little stuff in here. So this one I was mostly, I was pretty focused on just getting a whole bunch of these things on the slide when I was making this one. So this is kind of a mono slide. I'm not expecting to see too much more other than these guys here. Wow. Oh, it's always so cool to find like an organism that you're just not at all familiar with, and that just looks completely unfamiliar too. There we go again. Here's another one of those Vaseline dabs here. You can see here's some nice glass microspheres here. Those aren't bubbles, those are microspheres. They remind me of like cuttlefish or something, or squid. The kind of the shape of their body. Like they don't have the tentacles, but they've got that certain shape to them. So let's go back to the middle then, because we had that one that was kind of pinned down, which also looked different. It did look different. Now I'm like, dang, is that actually the same one? Let's see. Gotta be, right? I think so. You can kind of take a look at this thing and interrogate it with high magnification. So it looks like you can see sort of a kind of a noodly thing going across it. Let's get this. One second here. Let's get this in focus. Wow. This is with the 40X. Let's see. I think this is. I'm trying to remember how I actually. Oh, there we go. Yeah. Oh, yeah. All right, that's much better. Wow, look at how the cilia beat in waves. You guys see that? They really, like, the whole thing is just kind of waving. So here you can see it's almost like a sideways number 9. You can see sort of a structure, little squiggle structure in there. I'm pretty sure that is a macronucleus. This is the top, and we're kind of focusing on, ooh. Wow. Oh, this thing is tremendous. Oh, I can't get over the way the cilia are like really distinctly, like rhythmically beating. And then it's got this big, what looks like to be like a big food vacuole in the back. I see a diatom shell in there. That's a clue to how this thing gets energy. Whoa, really vibrating there. I'm gonna try to see if I can find one of the smaller ones here while I'm looking down here. The other thing that we've got in this, so this is, I think that's the top. Yeah, so the other thing that we have, this is really interesting. When I kind of poured these samples out into my Petri dishes, there were all these tiny little like particles, these like linear shaped particles floating around, and they were too small for me to really like see for sure what they were. But I did have a suspicion that they might be planktonic diatoms, and indeed we ended up with a whole bunch of these, and they have these really long apices right on the other side, these really long slender bits of their exo of their frustule, and that helps them sort of suspend themselves in the water, and they really do, they float there for a very long time once they're stirred up, so they really do kind of catch the water quite well. Oh, here we go. Oh, here's one on the move, and now this one's kind of on the other side. So it looks like these things have sort of their whoa. This sort of oral apparatus is like on one side, which I think is a little unlike Stentor. Stentor they're more symmetric. Oh, that one's got that. Yeah. But it does look it looks so super Stentor-ish. Like just in the way the oral cavity kind of spins down in there. Oh my gosh, it's fast. But they're not cecilids at all. They don't stop swimming. Wow. This one's got like a little, I'm pretty sure this is the same, but maybe this one got damaged or something, and it's a little more stubby. Ah. What a weirdo. Let's see. Human field, I guess. So this is dark field now. It's really I don't know, there's something going on here. stuck in a loop. What are you doing, little fella? Wow. Let's see, let's go here. Here, and they're quite dark because this is like here I've got it in bright field, and they're very, very dark. It's slowing down. Is it dying? It just seems to have kind of lost it here. Weird. Here we are back at the 10x objective. Oh, that is really something. Here. So yeah, anyway, these things were all over the sample, so I got a bunch of them and put them on a slide together. Well, here's some that are kind of expiring here. Something's wrong. They might be, I don't know, maybe they're like anaerobic or something. Anyway, we will move on. Let me put these guys back in the box. Alrighty. And we'll go to a slide that's a little bit more conventional. Whoa! A lot of diatoms. Wasn't necessarily expecting that. Let's see, let's pop this. Get up? Yeah. Whoa. So this is a slide. In one of my sample jars, I had kind of like a little stick floating around. Hello. And I used a little X-Acto knife to just scrape off some of the surface growth, and I kind of just scraped it off onto this slide, and everything we see here. And then I guess I did do a little bit of extra pipetting beyond that too. So. But yeah, it looks like this thing had a lot of tiny little diatoms growing on it. That's for sure. Wow. Oh, look at them all. They're so pretty. And there's so many. And yeah, I saw it had some of this little green spindly stuff. Little marine plant. Hey, here's one of our other little friends. These guys are probably going to be on a lot of slides tonight. They were all over. Like I was a little bit disappointed just in the sense that I didn't get a ton of like ciliate diversity this time. But I will always take a new ciliate. Let's see, what am I doing wrong? Oh yes, I need my polarizer up in here. Go. So we do have some rotifers in here. This rotifer is an interesting one. It's got quite a tail on it. Some rotifers have these like really chunky, muscular tails. A lot of rotifers just kind of have like a little kind of spindly tail, or I guess this is technically the foot. I should be proper about it. A lot of them are pretty uninteresting. But this one's got a real chunky one. Go to the 40X here. There we go. Nice. Yeah, look at that foot. It looks like there's kind of two like main tendons that are going down in there. Right. Maybe attached to each of the little toes there. And we got all of our little diatoms here. Ooh, and a little dinoflagellate maybe. Back to 20X. Here's one of our little friends again. Wow. Wow, there's just so much that was collected on this little stick. So many diatoms. that's weird. Hold on. What? Why is it that? There you go. See that? All right. Well, I didn't change anything, but all right. Sorry, just doing some OBS in the background here. There's lots of like little stuff floating around too. We got little silhouettes here. There's a little Hypertrick. That's kind of an interesting looking one. I don't know if that's a Euplotes. There's another little, like, just kind of... There's lots of, you know, anytime I go to marine stuff, there's always going to be a lot of stuff that looks a little unfamiliar. Surprising how much their stuff is familiar. There's like a lot of critters that are just adapt to the saltwater and are very similar to what you find in freshwater. Then there's stuff that is always very different. Is that a little amoeba there? Yep. Here it goes. Talking about its amoeba business. Let's do a little bit of phase contrast. Go. See, with phase contrast, the sort of inside of the amoeba, the whole thing is like shaded kind of darkly. One of the defining characteristics of phase contrast. It's such a there's so much stuff that it's very there's a lot of kind of like out of focus interference here. A lot of light waves bouncing around. Go away from the center maybe. And stuff. I love how these diatoms are showing up too. Their little apices or protrusions there showing up nice and dark in the phase contrast. Go to 10x. In the dark spot. And right down. Go. Wow. Wow. A lot of this stuff is showing up like so bright. I gotta like turn it down a bit. Maybe not a bad thing though, yeah. Wow. Like right, what do you think, like right there? Like haze contrast, nighttime, after dark. How about we do a little bit of polarized light? Get that out of there. Pop this in. Pull this in, pop that down. There we go. You got some stuff that's lighting up. A lot of stuff that is not, but we really crank the exposure. Here we go. You can check it out. Check out these kind of weakly interacting polarization objects. And once again, oops. Some of these diatoms have these red structures, but some of them don't, which is interesting. Always red. I don't know if you guys have been with me for a while or not. I'm kind of I've got a little mystery going on here. Why do these diatoms sometimes have, like, just where the chloroplasts are, they show up red in polarized light? Oops. And like, because if it was structural color or something, you would expect that would be coming from like the pores, and it would follow the pore patterns, but like it very distinctly follows the chloroplasts. And then you have stuff like this where it looks like only parts of the chloroplast are lighting up red. So why? What's going on there? Explain yourself, diatom. Unfortunately, the microbes rarely explain themselves. They rarely talk back. This is cool though. It's like a little confetti. Find something that's really active here. Oh, here's that rotifer again. Oh, hey! Oh, these things have crystals. Hey. I forgot to look at them before in polarized light. Now we can observe them. Wow. Oh, that's so pretty. It's very paramecium-like. These are all almost certainly not paramecium. But it's interesting because, like, you know, I've been saying that they kind of look like Stentor, but like one thing I do know about Stentors, they rarely have much in the way of these like mineral inclusions. Wow. Oh, these diatoms, these red diatoms, man. What is going on with you? I feel like somebody has to have like written about that somewhere, and it's just a matter of finding the right document, but no. Pretty. Wow, these things are like just full of these diatoms. That's a particularly golden one in the polarized light. Look at that little guy. All right, let's go ahead. Down there. We'll go back to DIC. Okay. Well, we got some little some cessilids here. And these look like they kind of all are sharing a stalk. Not like Vorticella, where the stalks are always individual. Yeah, these stalks are sort of branching, connecting. Oh, they all jump at the same time. They don't seem to be deploying their cilia. Those are neat. Ooh. Oh, these are cool. Are with the 40X. is all right on the underside of the cover glass. Oh, hey, wait, is that a... Oh no, I thought that was moving, but I don't think it is. That was you gleaned for a second. Yeah, just some little diatoms. Go back to edX here. I guess we're kind of at the end of this slide. Feels like anyway. I'm seeing not a super diverse slide. There's lots and lots of these diatoms. A couple of rotifers. Thought there would be more rotifers, to be honest. Okay, well, we will move on. Okay, so this one is actually not collected today. This was from a sample that I collected a couple weeks ago. And there's pretty much only one thing on here, and that is paramecium. I have a jar, and this is kind of... I've talked before about like sort of the fates of sample jars. You know, different things can happen over time, and one of the fates that I often observe with my freshwater samples is the paramecium snow, basically, where almost everything, like almost all the water everywhere, is just permeated with paramecium. And when you can look at it with your eyes, you can just see that there's tons of little white specks swarming around inside. Oh, there's a little Euclides. And wow. So this is a slide which I prepared with the small glass microspheres. This was kind of a deliberate attempt to see how these things behave there. And it seems to be pretty successful, because this is like right here. This is the underside of the cover glass, and that's the bottom of the slide. So it's just a teeny little bit of space, and it seems like it's a nice amount of space to sort of hold a paramecium without squishing it. And we got them. So now we've got them right under a 0.17 cover glass. Down a little bit. Here with the 20x objective. Wow. And you really do just get like here when I'm using the precision cover glasses, I've been really careful about preparing the slides. You do just get really, really nice imagery. You can just tell. You can just tell that you're. If one of them would hold still for me here. There we go. This is with the 40x. So I often do add water to my slides as I'm streaming, especially if I'm on one slide for a long time. But I actually have not added water to any of them so far in this stream. Give you a sense of that. These are some really skinny paramecia. Oh, picked up a little particle of something. So this is what I would normally call paramecium caudatum, but I've been informed that is not necessarily a reliable ID, that there are a lot of paramecium that look like paramecium caudatum. So we'll just call them paramecium. Let's see if we can find a place. Often these things will congregate somewhere. Let's see, here's my Vaseline. I don't see any of my... Maybe I didn't get any microspheres on this one. There we go. There you can see some. As long as I get them in 3, it should be pretty acceptable. Something else I could try too in the future is putting microspheres on only one side of the cover glass. And so I kind of create deliberately a glass that sort of pinches down as you go across. Oh, we got some paramecium here in the Vaseline. It's sort of like a crab pot almost. This could actually be pretty cool here. It's got a polarized light. The Vaseline itself has quite a polarization response. Still need to figure out why that is. I think that's pretty interesting. See if we can find a spot where they all are. These are just always so much fun to watch. It's twinkling. I really like watching paramecium polarized light. Ooh. Well, that's a nice little background. Ooh. A little bit of a velvet. I'm using a piece of acrylic over my wave plate right now. Just so many cool effects that we can hit. Ooh. Got a little bit of like, this is similar to my like purple green, but more like blue green. See if we can hit something else. Okay. See, let's try that. Magenta. Use magenta. This. Bear with me here as I do some testing. Yeah, so if I turn it that far, it ruins it. Interesting. Whoa. Yeah, quite a strong green there. Again, this is just this is all polarized light stuff right now that we're doing. I do like, this is a fun effect too. I like the kind of baby blue background with the polarized light. Let's see with that. Yeah, oh yeah, the Vaseline's crazy, right? Without the plexiglass, the acrylic rather, and that's just straight up polarization. Cool stuff. back. No. Back down to where the Vaseline was. This is with the 40X, but they're moving too fast for me. Awesome. Very fun. Always fun to have a slide with a bunch of paramecium on it. Okay. And now we will go to probably be our last slide of the night. This one's a little bit more like I didn't really I didn't do too much like super deliberate pipetting. I definitely did some. Pop this up in here. There we go. Put that down. And bring this over. Yeah. So this is just another slide that kind of just I found a couple interesting things and put them on the slide. And then let's see, did I use yeah, I did. I used my larger glass spheres for this. So this is sort of a suspended cover glass. And that's because I had some larger critters on here that I didn't want to outright squish. Let's see if we can track them down. Whoa, look at these. Oh, have these been in all of our samples? Whoa. Check these things out. Hold on, let's see. So if I did this, then it was probably over here. These little things. If I can get them in focus here. Whoa. They have, it looks like 2 flagella. Let's see if I push this down a little bit and turn up the exposure. Maybe that'll help. Yeah, whoa. Oh, these things are weird. Those flagella are so long. And they're like... They're really just kind of dragging them. I wonder if these things have a polarization response. Weird. I don't know if those are in the other samples or if I'm just noticing them now. Okay, let's see if we can't find our stuff that I deliberately put on here. Wouldn't be too hard to find. So that's oh, hello. I think that was one of those ciliates there. I'm using my 10x here. Hello. There's a piece of something. Oh. Okay, now come on. There was definitely some stuff on here. There's a little copepod deer. Might have to go to the 4x here. Get a better view. Okay, there's one little guy. Got all the way to the edge. That's not really what I was looking for. Sorry, it's taking me so long here. Oh yeah, there's one of those crazy ciliates. It's very pink. Come on now. Oh, there's another ciliate. I'm just not seeing it. They wiggle off the slide. Sometimes that happens. Oh, here's that. Okay, that thing's doing okay. I thought that was maybe dead. Ah, yeah, here we go. Oh yeah, here they are. That one might not be doing so hot. But found some more of these. And these are polychaete worm larvae. Of some variety. And it looks like this was a pretty good fit for this one. The other one was over here, right? Yeah. Well, this one's not fluttering anymore. Not looking so hot. That's the Vaseline. Right there. So let's see. I'll try to put a little bit of water and just see if it gives this thing any kind of extra nudge. I do remember it kind of squirming around a little bit when I put it on here. You can go to PIC. And get a look at this little larva. Oh, oh, here comes this little shrimpy duder. Don't bury yourself in the Vaseline. This thing's got diatoms like shagging off of it. Let's see. Let's go to polarized light. Not much going on. That's interesting. I remember for sure there was oh, there we go. It's at least. I remember the last time I messed with these things, they had a lot going on, but it was probably a different species. I can see this thing and its incredible eye that just absolutely glows in the polarized light. Not a whole lot going on with these. Wow. The Vaseline, man. It's just wow. I still can't get over how like strong of a polarization response that. Okay. Investigate the other little critters on this slide. Like red diatoms. Oh, whoa, look at this. We got some, looks like a mating pair. Or maybe they're just good friends, who knows? Let's go to use this. Dust off this old condenser. I haven't used my phase contrast condenser in a minute. So we'll just use it to get some dark field going here. Go to here, and then we can center it with the low mag. Thusly. And then bring it up. Down. All these little tiny duders. Poking around here, see if there's anything else going around. Oh, we do have something. This looks like oh. Wow. Oh, these things are so cool. Dang. Wow, these things are just absolutely wild. Sorry, I got sidetracked. They really do have that pinkish color, huh? Let's see if I can wipe that off. There we go. Oh, there's an interesting little guy. Whoa. It's a curiously... That's a weird little ciliate. It looks like a colpoda, maybe. It's got kind of a colpoda shape. But the inside area, like, it's brighter. Pretty unusual for a ciliate. Whoa. Let's see, you have a polarization response. Answer seems to be not tremendous. So, whoa. Okay, let's get it under TIC. Is it one of those ones that kind of has like a backpack? I think maybe one of our oh, that's right, I took off my TIC condenser. Oh, played myself. We're gonna be lucky if we can find this thing again. Oh, hey, look at that. It's right there. That's very convenient. Let's see. I'm doing something wrong though. Let's see. That should be okay. I'm not getting my extinction here. Stand by. Let's see what Jason forgot to do. Right, that's in the right way. I swear, guys. Sometimes. This is... Yeah, what the heck? What's going on here? This is the 20X. I'm on the 20. What am I doing? Yeah, it just looks like the polarizer's not working. What the heck? Gosh. Make sure, let me look at this thing, make sure I don't have anything weird going on with this. Yeah, okay. Normal. What the heck? Oh, I'm just stupid. There we go. Okay. Gosh. I think it's going to need to be an early night for me. There we go. That looks better. That looks better. Just didn't have my condenser at the right height. There we go. Now I get a nice view of this thing. Let's see, this is... Yeah, this is the tall beads. So this would have been like that. There we go. Oop, oop. Down. Now it's near the bottom, so that's why you can see it's kind of soft, kind of not sharply focused. Oh, but here it's coming up to the top, and here you see when it's up at the top, it's very nice and sharp. But now it's going back down. Theoretically, I could try to like change this. Oh, now it's at the top again, so I gotta change this back. Yeah, that's definitely a little too much work. Hey, Jeremy, welcome in. Welcome from Florida. Pretty late in Florida. This is a cool little ciliate here. It's got some interesting stuff going on. You guys also see it's got like there's almost like these little like nodes around the perimeter. Yeah, like it's got like little spines almost, like in addition to the cilia. And it's got other stuff too. There's other like little spherical inclusions in this thing. This is a really interesting silhouette. Just in terms of a lot of little features. Where are you? Oh, hey. Stop resisting. Where'd you go? Dang. There's a dinoflagellate there. There's another one. Whoa. Whoa, this thing's got one hell of a flagella on it. This one's farther down. Come back like that. That looks pretty decent. With the 40X here. It looks like this thing eats diatoms, actually. Got that like one feeler flagella and then just the super long trailing flagella. We got a little silhouette here. This is sort of Pyrostomum-ish. It could also be Gruberia. Or it could be something completely different. Got an interesting twist on its membrane. Twisty membranes are always interesting. See, it's got a little vacuole at the back end of it. This big thing's cool too. Yeah, there's more of these things, huh? Oh, there's a cool little yeah. So here we have spirochete bacteria. These ones are crazy, man. The ones that are like super tightly corkscrewed like this. The way they move, it is quite alien. Spirochete bacteria, that's what causes syphilis. My understanding is basically they sort of corkscrew into your bloodstream. Like a wine opener. Whoa. Yeah, this thing is so cool. More of them. And they all look like they have some diatoms inside of them. I'm searching around for the right one. Ooh, these are some pretty diatoms. Like epithemia. And these ones here, this is very marine. I've never seen a freshwater diatom that has this structure with the 4 little spines. But that'll make this thing very, very planktonic. It'll float very well. It'll sink very, very slowly. And some of these kind of stuck together. Oh, here's a little mat. A little like biofilm mat here. There's some nice bacteria. And diatoms and algae. And a nice little ciliate in there too. Hey, and a nematode. Might be the first nematode we actually saw today. Unusual, since they're usually so ubiquitous. Whoa. Whoa, check out that diatom. What is going on? Whoa. That thing is infected. I wonder if that's a fungal infection. You can see the little protrusions have segments, kind of long segments. I mean, it's also possible that they're bacteria, but then I see what's going on inside of it, and that looks like that's abnormal for sure. Okay, there it is. Let's get this up to the right spot. Okay. Okay. I anticipate here. All right. Actually, let's. Okay. Prepared first. Okay. This should be pretty straightforward. Drop it. Dab of oil. And come up. There we go. Oh, we need to probably also drop a little oil in this bad boy. Okay, there we go. Sorry for the delay. See where that thing get off to. Dark heat. Oh, there it is. Whoa. It actually got kind of far. Okay. So here we go. This is with my 60x 1.4 numerical aperture. So you can really get a good view of those little things inside of it. Sure thing, Sid. Thanks for stopping by. Interesting. Like those are definitely foreign foreign bodies. Those are not part of the diatom. Or at least not typically part of the diatom. They are now. And it's interesting to me that this diatom is still alive and like moving around. I'm sure if it could perceive any kind of discomfort, it would be in a lot of discomfort right now with this stuff hanging off of it and this stuff growing inside of it. The IC doesn't work quite so well with 60X. Yeah, we're doing 60X oil immersion, so the 1.4 numerical aperture lens. Humidity. Let's take this out. Wow. All sorts of little doodads going around. Oh, here's some cool little bacteria. Are these little? I think no, they're individual little bacteria. Oh, you can see the. Oh, we can just barely see it. If you guys, I don't know, this might not come through on YouTube after the compression. Let's see if we can find another one. But we can see the bacterial flagella, just barely. You can guys see the, oops, oh, where'd it go? Yeah, here. You guys see just barely when it's holding still. There's a little swishing organelle. I still don't. one thing I haven't figured out is what the heck this like greeniness is in the background. And I wonder if it might actually be like my image sensor. It might be the kind of the glass above it or something. Whoa, check this out. This diatom is also infected. Oh yeah, you can see it's got the same things. Well, these I remember these crazy like swarming, these little I guess they're little spirochetes. And I've seen them before, and they like to swarm around things that are photosynthetic. That's a little cyano there. These are little cyanos. I don't think these swarming things are cyanos. Nice. The diatoms. Always fun to look with this, like, whoa, hey. Whoa. Here's our little copepod duder. Oh, I love these lipids here. Oh, hey, is this that ciliate? Yeah. Oh, come back here. I think that's the same one. Yeah. Yeah, this is cool. You can really see the shape of this thing. And it looks like it has a little mouth part there on the front. Now that I look more closely, I think I helped someone identify one of these before, but I don't remember what it was called. Little green duder. this one looks like it's sort of in the process of being infected. That one on the bottom left there. And then the one on the right, look at that. That one is Dunzo. I think that's just a single valve, and it's still got those protrusions on it. Dang, this is hardcore. There's a little tool for fixing bacteria. Okay, well, I think we'll go ahead and call it night here. Ooh, that's a nice big frustral. About 2 hours tonight. Yeah, I'm pretty pleased with the results that I got with my my new microsphere technique. Go check out those. Here's one. So yeah, I'm pretty happy that I think there's room for improvement, and there's definitely room for like I don't know how to best wield these yet, but I think there's more stuff that I can think of in the future. But it does seem like a cool way to sort of not have to use deep well slides, which can be kind of annoying for numerous reasons. So yeah. Anyway, thanks so much everybody for tuning in. And I think this week I'm flying out to St. Louis. I'm flying out on Wednesday, and I'm flying back on Thursday. And I'm planning to take some jars with me and maybe do some remote collection. And so I might try to do something like on, I don't know if I'll do it on Friday, but maybe like Saturday, like Saturday afternoon, maybe do like a Twitch stream, do a European friendly Twitch stream or something. Yeah, stay tuned for that. I'll probably mention that on my Discord at some point. So, yep. See y'all next week, and have a good night.